Everyone, I'm Rohit. I'm going to present a new project presentation based on the domain machine learning, namely heart disease or heart attack prediction using machine learning and web app deployment. The main aim of this mini project is to predict whether a person or a patient is having a risk of heart attack or heart disease or not by using different machine learning techniques. So what can cause a heart attack? A heart attack occurs when one or more of your coronary arteries became blocked. Over time, a buildup of fatty deposits, including cholesterol from substance called plaques, which can narrow the arteries, or atherosclerosis. This condition called coronary artery disease, which can cause more heart attacks or heart diseases. So what are the steps that I can do in machine learning code? First one, we can import the libraries and then we can import the dataset. Then we can analyze or visualize the data by using histogram, bar plots, etc. Then we can standardize the data using the data standardization. Then we can create different machine learning models. After creating the machine learning models, we can store the ML model in pickle module. Then we can do some predictions, and lastly we can deploy the web app. This is the timeline of the project, which was I have been explained in the previous slide, that contains such steps which have been explained. So let us move to the next slide. So these are the libraries which I am importing in machine learning code. First one pandas, and second one is numpy, which can import the dataset. Third one seaborn, and fourth one is matplotlib, which is used to analysis and visualize the data. Fifth one is standard scalar, which is used for standardizing the data values. Logistic regression support vector machine, decision tree, confusion matrix, and k-nearest neighbors, which is used for different machine learning methods which can be done in project code. Next is grid search CV. It is the internal cross-validation technique which is used to calculate the score and combination of the parameters of the grid. And next is the ADA boost classifier. It is a boosting algorithm that also works on principle of the stage-wise addition method, that we can combine the weak learners into strong learner. So this is the flowchart of the web app. We can fill the details before clicking the predict button. Then we can predict the result which was been displayed. If not, you can select from drop down menu. Then we can fill the details mandatory, and we can click predict button, and then we can predict the result value. So this is the web app predicted model. Model deployment is the last stage of the heart disease prediction machine learning project. By using Flask to make a HTML file of heart disease prediction, the web app will be deployed on Heroku, that is the cloud platform. This will take the input values of each person or a patient and gives the predicted result. How the web app prediction model works. After entering into the data in web page, it will be posted into the ML model through pickle file. An ML model will be calculated and gives the predicted value or predicted result. Then the predicted result will be visible in the web page. So this is the required inputs for diagnostic test results. First one is chest pain type, resting blood pressure, serum cholesterol, fasting blood sugar, reading ECG results, maximum heart rate, exercise including angina, ST depression, slope of the peak exercise ST segment, number of major vessels, and thalassemia. The first label is the chest pain type. Chest pains is the common cause which is not always related to an underlying condition. It may be caused by lifting the heavy weights, anxiety, trauma to the chest, flatulence, and heartburn. Next is resting the blood pressure. Your blood hits the wall of the arteries with some force which can cause blood pressure. That is the serum cholesterol. Means there are two types of cholesterols are there, bad cholesterol and good cholesterol, which is bad cholesterol which is in LDL, and good cholesterol HDL, and triglycerides will give you a number called your total blood cholesterols or serum cholesterol. Your serum cholesterol levels can help your doctor figure out your risk of the developing heart disease in the next 10 years. Next one is fasting blood sugar. What is fasting blood sugar test? Fasting blood sugar test, a blood sample will be taken after you haven't eaten anything the night before. A fast blood sugar level less than 100 is normal, and it will be increasing at 125 is considered as pre-diabetes. Next one is reading the ECG results. That is, electrocardiology is the process of producing an electrocardiogram, a recording of the heart's electrical activity through repeated cardiac cycles. Next one is maximum heart rate or pulse rate, is the frequency of the heartbeat measured by the number of contractions of the heart per minute, or we can call as BPM, beats per minute. Next one is exercise including angina. Angina is also known as angina pectoris, is chest pain or pressure usually caused by insufficient blood flow of the heart muscles. Myocardium is mostly common a symptom of coronary artery disease. Next one, ST depression. Electrocardiogram finding ST depression refers to a finding out an electrocardiogram wherein the trace of the ST segment is abnormally low below the baseline. Next one is slope of the peak exercise ST segment. This is a measure of the changing the ST segment of the electrocardiogram during the different exercises, that is upsloping, flat, and downsloping. Next one, the number of major vessels. The number of major vessels that brings blood to and from heart. There are 5 types of major vessels: superior vena cava, inferior vena cava, pulmonary arteries, pulmonary veins, and aorta. Next one is thalassemia. Thalassemia is inherited blood disorder in which the blood body makes an abnormal form of hemoglobin. Hemoglobin is a protein muscle in the red blood cells that carries oxygen. As you can see, the blood cells were in the circle. Where the thalassemia occurs, the malformed red blood cells will be shaped out. This is the final predicted result, and this is how the web app works. You can see in this video. This is the Python code of the web app. Then I typed Control C. When I run this app, I got the web app link and I click the command Control click. Then it shows the output of the web app. Then I'm entering the diagnostic test results from drop down menu. For example, I'm taking the age 60, sex gender is male, chest pain typical angina, resting blood sugar is 90, and serum cholesterol 0. Then I taken the flash blood sugar is less than 120. Then I'm selecting the EGC result normal, selecting the heart rate 71, engine as yes, ST depression I'm selected as 0, slope of the peak exercise ST segment upsloping, then number of major vessels is 2, then thalassemia is normal. After selecting all the values in drop down menu, then I get the result that you don't have chances of heart disease. When I changed the serum cholesterol into 56 and I selected the gender, when I click the predicted button, as you can see, the result has been changed that you have a chance of heart disease. So this is how the web app works. And finally, in this project, I'm able to apply a machine learning algorithm and used it to predict the heart attack probability to the patient by inputting the diagnostic test results. A proper implementation of the model can provide the correct information. Several data features were extracted from data set to ML model for predicting the result. With the help of ML techniques, my model will be able to predict the accuracy of 85.71, which is good and reliable. The prediction of the training data is compared with the prediction of the testing data. That the training data is 70% and the testing data is 30% by applying all the ML techniques and operations to make the final prediction of the ML model. So thank you. Thanks for watching.